A miniature UAV or small UAV, SUAV, is an unmanned aerial vehicle small enough to be man-portable. Miniature UAVs range from micro-air vehicles, MAVs, that can be carried by an infantryman, to man-portable UAVs that can be carried and launched like an infantry man-portable air defense system. SUAVs have been given various definitions among national regulation authorities, often without including size precisions and differing about weight measurement specifications. Those definitions range from less than 2 kg for Canada to less than 25 kg for the United States. UE's Cesar perspective for the 2020 Air Traffic Management Rules also proposed less than 25 kg, while UK's CAA stated less than 20 kg. MAVs and messicopters. The notion that small, even very small, UAVs might have practical uses arose in the early 1990s. In 1992, DARPA conducted a workshop titled Future Technology-Driven Revolutions in Military Operations. One of the topics in the workshop was mobile micro-robots. The idea of using very small micro-drones was discussed, and after initial skepticism the idea started to gain momentum. The RAND Corporation released a paper on the micro-drone concept in 1994 that was widely circulated, reference 12. DARPA conducted a series of paper studies and workshops on the concept in 1995 and 1996, leading to early engineering studies by the Lincoln Laboratories at the Massachusetts Institute of Technology, MIT, and the U.S. Naval Research Laboratory, NRL, in Washington, D.C. The studies demonstrated that the concept was feasible. In 1997, DARPA then began a multi-year, $35 million development program to develop micro-air vehicles, MAVs. The MAV project's goals was to develop a micro-drone whose largest dimension was no more than 15 centimeters, 6 inches, would carry a day-night imager, have an endurance of about 2 hours, and be very low cost. It would operate with a high degree of autonomy to be used in the squad-level combat environment. MAVs capable of hovering and vertical flight would be used to scout out buildings for urban combat and counter-terrorist operations. A MAV could be included in a pilot's survival kit. A downed pilot could use it to keep track of enemy search parties, or as airborne radio relays to search and rescue units. Phase 2 MAVs. This Phase 1 DARPA study ended in 2001, and was followed by a Phase 2 study that focused on particular vendors with an intent to develop MAVs closer to operational specification. A number of different MAVs were developed as part of these DARPA efforts. Lockheed Sanders Microstar. The Lockheed Sanders Microstar series of prototypes. The battery-operated Microstar designs resembled kids' toys. An initial design had a fat teardrop body with stubby cropped delta wings running along most of the body, along with a single vertical tailplane and a pusher propeller. A later version had winglets instead of the single vertical tailplane, and a nose-mounted propeller. The Microstar featured a 5-gram navigation system that could be given directions by the ground station, but could also automatically keep on a heading or orbit a target. CIT, AeroVironment, and UCLA Microbat Ornithopter. The Microbat Ornithopter from the California Institute of Technology, Caltech, working with AeroVironment and the University of California, Los Angeles. The ornithopter design concept followed experiments conducted in the mid-1990s by Charles Ellington, a zoologist at the University of Cambridge, and his colleagues, in which mechanical analogues of insect wings were tested in a wind tunnel. The group was only interested in studying the biomechanics of insects and was extremely surprised that somebody seemed interested in them. The Caltech/AeroVironment Microbat Ornithopter was test-flown for short distances under battery power. Researchers performing flight tests with the Microbat said it tended to attract small birds when it ran low on power and fell to the ground. The birds clustered near the floundering ornithopter in what seemed to be a desire to help. Other research groups also worked on ornithopters. A Georgia Tech Research Institute group built a rubber band-powered entomopter and also did research on a chemically powered reciprocating chemical muscle propulsion system. Lutronix Corporation Colibri Microhelicopter. The Colibri microhelicopter built by Lutronix Corporation of Del Mar, California. The Colibri, German for hummingbird, was larger than the other DARPA MAV prototypes, with a weight of about 300 grams. The Colibri was built as a cylinder with rotors at one or both ends, using vanes moved through the rotor airflow by piezoelectric actuators for flight control. It was powered by electric motors or a tiny, highly efficient multi-fuel engine developed by a company named D-Star. Microcraft SLADF duct fan microhelicopter. The small lift augmented duct fan, SLADF, duct fan microhelicopter, built by Microcraft of San Diego, California, and Ontario, Canada. The SLADF was a duct fan helicopter with a diameter of about 15 centimeters, 6 inches, and a weight of 1.8 kilograms, 4 pounds, with payload. Interestingly, the SLADF did not appear to use a contra-rotating rotor design, using a single rotor with aerodynamic deflection surfaces inside the duct to cancel torque. First flight test of the SLADF was in late 2000. The SLADF could be fitted with an optional wing to provide useful lift to increase loiter time, and also provided additional fuel storage. AeroVironment Black Widow Flying Wing. The AeroVironment Black Widow MAV. Developed by a team led by Matt Keenan, the Black Widow was powered by electric motor driving a small propeller in the nose, with a lithium battery permitting about 20 minutes of flight. It carried an off-the-shelf camera chip giving it a color video resolution of 510 by 492 pixels. While the first Black Widow prototype was a flat disc with a single vertical stabilizer and a propeller in the front, it was followed by an improved Black Widow that looked a little like a thin portable CD player with tapered edges and cut-off corners, a propeller in front, and 3 fins on the back. It did not have autonomous navigation capabilities, and was controlled essentially like a hobbyist's RC airplane. Subsystems design. Along with the flight prototypes, the DARPA effort considered subsystems design. A useful operational MAV would need a lightweight, highly efficient engine with a power source with high energy density. Electric motors were becoming available that met the requirement, but power sources were more troublesome. Lithium batteries were marginal. New compact fuel cells were in development but weren't expected to be available for several years. One particularly intriguing option for both propulsion and power was a button-sized silicon microturbine, JET, engine developed by Dr. Al Epstein at MIT during the 1990s. Silicon was actually a good structural material at such scales, though increasing operating temperature would have dictated use of silicon carbide. A production device was envisioned as a centrifugal flow engine about 2 centimeters across burning natural gas, with a single turbine disc for compression and a single disc for exhaust rotation. The design didn't look much like a conventional turbojet, resembling more a tiny flat cylindrical box with an inlet hole on one side and an exhaust hole on the other. It was expected to have a thrust-to-weight ratio of about 100, incredible compared to any macro-scale engine but a logical consequence of scaling the technology down in size and run at about 1.2 million RPM, making bearings a tricky issue. Since it could spool up in about a millisecond, it was envisioned as operating in a pulsed mode to conserve fuel and also provide a throttling scheme. A functioning gas turbine was never successfully implemented at this scale after years of development. Other tricky issues were control systems, since an MAV couldn't be flown like a model airplane and would have to be able to tolerate turbulence and wind gusts, and miniaturizing navigation, communications, and sensor systems, as well as ensuring that they didn't interfere with each other. DARPA specified that the payload would be no more than 15 grams. Stanford Messicopter. As extreme as MAV specifications were, a team under Island Crew at Stanford University worked on an even more extreme design in the form of a centimeter-wide 4-rotor Messicopter using microcircuit fabrication techniques. The work was funded by NASA. Design of such a small aircraft was constrained by the fact that at such scales, the air becomes a highly viscous medium, or in aerodynamic terms a Messicopter had a low Reynolds number. Basic aerodynamics of the Messicopter were defined by a cycle of computer simulation, followed by tests of model components. The research led to Messicopter rotor designs where the rotor looked much more like the blades of an ordinary room fan than the rotor of a conventional helicopter. Propeller designs did not achieve desired efficiency and the messy copter was never able to lift the weight of its own energy source. MAV's rethought. The DARPA MAV effort ended in 2000 and the results of the effort were somewhat negative, demonstrating that a 15-centimeter UAV was simply too small to be useful or even workable, at least over the short run. However, though the size was unrealistic, the basic concept seemed valid even if a larger machine were needed. DARPA did begin a follow-on effort in the spring of 2002, working with the U.S. Army on a larger ducted fan vehicle as a follow-on to SLADF under the Organic Air Vehicle (OAV) program. Allied Aerospace, which had bought out Microcraft, demonstrated a scaled-up SLADF, while Honeywell performed tests with their own ducted fan vehicle, named ISTAR. However, neither vehicle seemed particularly promising and the program was cut short. It was revived as OAV-2 in 2004, with DARPA specifying a diesel-powered ducted fan vertical takeoff UAV with a weight of 51 kilograms, 112 pounds, including a payload of 10 kilograms, a range of 10 kilometers, 6.2 miles, a top speed of 92 kilometers per hour, 50 knots, the ability to hover in a 37 kilometers per hour, 20 knots, wind, an endurance of 2 hours, and a ceiling of 3,350 meters, 11,000 feet. The OAV was to be carried, launched, and recovered on a Humvee, using a crew of 2 soldiers, who would be able to get it flying in 5 minutes. Its sensor systems will be able to provide targeting data to within 10 meters, 33 feet, to support non-line-of-sight weapons. The UAV would have autonomous flight capabilities with the ability to maneuver in cluttered terrain using an all-weather obstacle avoidance system, and DARPA wanted it to have the ability to land and conduct observations from its landing site. Other possibilities were use of the UAV for communications relay, SIGINT, countermeasures, or even armed attack. The Army was interested in the program, but its current status is uncertain. It may have disappeared again, and if so it may reappear once more. Black Widow, Wasp and Hornet. AeroVironment has also worked on follow-ons to its Black Widow, named the Wasp and the Hornet. The Wasp is a flying wing, with the wing in the form of a rectangle with a slightly swept leading edge. It is propeller-driven, with the propeller in front. The Wasp's main improvement over the Black Widow is that the lithium-ion battery and wing structures are one and the same, allowing maximum battery capacity relative to MAV size. The Wasp has a wingspan of 33 centimeters, 13 inches, and a weight of 210 grams, 6 ounces. Like the Black Widow, the Wasp is radio-controlled. In the spring of 2003, AeroVironment performed the first flight of the Hornet, which is similar to the Wasp but has a straight rectangular wing with a slightly greater span of 38 centimeters, 15 inches, and, more significantly, is powered by fuel cells. The fuel cells are built into the top of the wing, where they combine oxygen in the ambient air with hydrogen produced internally by the MAV through reaction of a hydride material with water. The fuel cell system is expected to provide 3 times the endurance of batteries of comparable weight, though early flights were limited by the tendency of the fuel cells to dry out. DARPA is actually more interested in the battery-powered Wasp, but other interested parties in the U.S. defense establishment, particularly the NRL, are very intrigued by fuel cells, and so DARPA is hedging its bets. Ultimately, AeroVironment engineers want to fit their MAVs with an autopilot and a color video camera. French Mirador. The French have done work along similar lines, with the French Defense Procurement Agency, DGA in its French acronym, sponsoring a flight demonstrator, the Mirador. It was a fixed-wing, propeller-driven aircraft 25 centimeters, 9.84 inches, long and was powered by miniature fuel cells that gave it an endurance of about 20 minutes. It was built by the French Defense Aerospace Research Agency (ONERA), working with the Royal Military Academy of Brussels, and is primarily intended to be a test bed for miniature sensor technologies. The DGA envisions an operational MAV as about 40 centimeters, 16 inches, long, with a weight of less than 1.5 kilograms, 3.3 pounds, an endurance of 15 minutes or more, a ceiling of 100 meters, 330 feet, and an operating radius of a kilometer, 0.6 mile. For the moment, the concept seems strictly experimental. Future smaller MAVs. The notion of bird-sized or even insect-sized MAVs has not disappeared, but is seen as a project for a future generation. MAVs have attracted a hobbyist and amateur community, similar to the robot combat competitions sometimes shown on television, and yearly competitive events have been conducted. These home-built MAVs necessarily show ingenuity rather than sophistication, but offer hope for an idea that will catch on. Research in 2005 included a model utilizing ground effect at NPS, Delphi at TU Delft and Wageningen University, etc. Some also consider using a reciprocating chemical muscle for actuating flapping wing MAVs such as the entomopter pioneered by Robert C. Michelson of Georgia Technicians Nonprofit Research Institute. Gun-launched and parasite UAVs. MIT WASP. The U.S. Army has been interested in developing MAVs that could be deployed as munitions, fired from artillery or unguided rocket launcher pods. A research team at the Massachusetts Institute of Technology, MIT, has developed a prototype artillery-launched UAV. The UAV, named the Wide Area Surveillance Projectile, WASP, no relation to the AeroVironment WASP, is fired out of a 127 mm, 5-inch, naval gun. The MIT group modified a standard illumination flare round to serve as the external case. After firing, the shell popped out 6 fins to keep it from tumbling. Once the shell was 20 kilometers, 12 miles, downrange, a parachute popped out of the tail to extract the drone. The parachute slowed the drone, which then unfolded into flight configuration. The WASP had a folding V-tail, a folding 2-blade propeller up front, and 2 straight folding wings. The wings were folded into 6 sections and unfolded into a total span of 94.5 centimeters, 3.1 feet. Once unfolded, the right wing was higher on the fuselage than the left, a result of the packaging scheme. The WASP drone had a flight endurance of 15 minutes, including 10 minutes of powered flight and 5 minutes of glide. It had a tiny camera in its lower fuselage, and relayed both imagery and its own current GPS coordinates back to the warship or artillery battery that fired it. At least 2 WASP prototypes were built and tested. After initial announcements of the effort, the whole thing went quiet, but it certainly remains an interesting possibility. Wingstore UAV and Raytheon Silentase. The Army had also worked on a UAV that could be launched out of a 70 mm, 2.75-inch, unguided rocket pod mounted on a helicopter and could also be carried by larger UAVs. This Wingstore UAV was 1.8 meters, 6 feet, long, and was fired out of the launch tube with a solid rocket booster. It then deployed wings, tail, and propeller, and cruised for up to 2 hours on electric power at a speed of 185 km per hour, 100 knots. It could carry a small daylight or infrared camera. Details of the Wingstore UAV are unclear, but it may have had some resemblance to the Raytheon Silentase UAV. Silentase looked like a simple metal cylinder with a rounded cap, straight folding wings mounted in the middle of the UAV and with a noticeable dihedral, and a folding inverted V-tail. The UAV was 46 centimeters, 18 inches, long and less than 7 centimeters, 2.75 inches, in diameter. Raytheon called Silentase a parasite UAV, as it would be dispensed from a larger UAV such as a Predator, a gliding submunitions dispenser, or a cruise missile. The baseline version of the Silentase would be strictly a glider, but its glide ratio of 11:1 would allow it to stay in the air for a half hour if released from typical Predator operational altitudes. It would be used for close-up examination of targets spotted by SAR to ensure that they are valid targets, or for post-strike target damage assessment. The little UAV could carry a gimbaled infrared or color TV camera, with the video compressed for transmission by a UHF communications link over line-of-sight ranges. It could also carry a jammer payload, or a small warhead. Since multiple Silentase would be deployed at the same time, each could be assigned a different code or telephone number to minimize confusion in communications. Raytheon was aiming for a target price of about $5,000 to $10,000. The company was considering a powered version of Silentase with a microjet engine, as well as stretched versions of the UAV. The Silentase has been cancelled. Italian MALP. Galileo Avionica of Italy is currently working on their own parasite UAV, called simply the Miniature Air-Launched Payload, MALP, to be carried on a Falco or similar UAV. The MALP has large cruciform tail fins, small cruciform nose fins, and switchblade wings stowed back along the fuselage that pop out straight when the UAV is released. It is intended to carry imaging or other sensors to probe dangerous targets. Man-portable UAVs. There is actually a great deal of activity in the small UAV field, with a number of systems now being acquired and some being used in combat. AeroVironment Pointer and Raven. In 1999, the U.S. Army bought 4 AeroVironment Pointer small UAVs for testing in the service's military operations in urban terrain and was enthusiastic about the usefulness of the pointer. The pointer system is too large to be conveniently carried by soldiers and is normally hauled around in a HMMWV, Humvee, vehicle or the like, and so the Army asked AeroVironment if the company could come up with a more portable solution. AeroVironment agreeably developed a half-sized control system and a cut-down version of the pointer called the RQ-11 Raven, no relationship to the flight refueling Raven. The Raven has the same configuration and central pod of the pointer, but a shorter tail and a wing reduced to a 52% span of 1.34 meters, 4 feet 5 inches. The Raven has an endurance of 90 minutes on rechargeable batteries. A 4-mission loadout can be carried by a single soldier along with all of his other standard battle gear. Following the Afghanistan campaign in 2001-2002, the US SOCOM ordered 80 Ravens from AeroVironment, which was more than the total number of pointers that had been sold to that time. The U.S. Army also placed orders for up to 105 Ravens in the late summer of 2003 after the U.S. occupation of Iraq led to persistent insurgent attacks on U.S. forces. Since then, the RQ-11B Raven B has become the official standard SUAS, Small Unmanned Aircraft System, for USSOCOM, U.S. Army, U.S. Marines, and several countries. As of early 2008, over 8,000 Raven airframes have been shipped to customers worldwide. Ravens have been operational in combat in Afghanistan, Iraq, and other undisclosed locations. Encouraged by such successes, AeroVironment is also working on a newer version of the pointer, named the Puma, with greater endurance and payload. In addition, they have disclosed that they are in late development of a small lethal UAV. AeroVironment Switchblade. In September 2011, it was reported that the U.S. Army had signed a contract with AeroVironment for the supply of the Switchblade miniature drone. Switchblade is the first tactical armed drone for use by a soldier as part of their backpack kit and weighs around 2.5 kilograms. The mini-drone has a small warhead and is launched from a 60 cm long container/launcher tube. As it launches, its small wings unfold and can be guided to its target via a nose-mounted camera. The operator looks through a viewer that displays video from the drone. Switchblade can also be directed to coordinates using Global Positioning System, GPS. Powered by an electric motor, it can reach speeds up to 80 km per hour and loiter for up to 40 minutes. The U.S. Army put the Switchblade into operation in June 2012. Reports of the range of the version used by the Army vary, however, with reported ranges including 5+ kilometers, 12 kilometers, and 40 kilometers. Interspect UASB 3.1 Flying Lab. The Interspect UASB 3.1 is a remote sensing platform for 3D photogrammetric purposes. The Interspect UASB 1.1 octocopter first flew on April 10, 2011. The prototype had one DSLR camera and limited capability. The third variant able to fly 12 minutes with 3 kg loading. Interspect UASB 3.1 have a removable 3D photogrammetry camera with humidity meter and other instruments. The octocopter's diameter is 1,165 mm. Arion Labs Scout. The Ariane Scout is a man-packable quadcopter UAV designed for aerial reconnaissance by users with minimal training. Weighing just 1.3 kilograms, it features onboard intelligence, all-digital communications, and a map-based touchscreen control which enables new users to operate the vehicles with only minutes of training. This map-based control allows the system to be easily controlled beyond line of sight and at night, a unique feature of this system. Its unique modular design allows for quick connect payloads of different types, and its arms and legs are changeable in the field, with no tools. This allows the user to repair damages easily and return to operation quickly. The Scout is approximately 0.8 m from propeller tip to tip and operates using 4 brushless DC motors, making it very quiet. It has an endurance of approximately 20 minutes. It is capable of flying in winds up to 50 km per hour and designed for all-weather operation, with an industrial temperature range. It has a payload capability of approximately 250 grams. It has been designed for both military and civilian use, with specific focus to remain dual-use compliant. Ariane Labs Sky Ranger. The Ariane Sky Ranger builds on the capabilities of the Ariane Scout and is a man-packable quadcopter UAV designed for aerial reconnaissance by users with minimal training. About 1 kilogram heavier than the Ariane Scout at 2.5 kilograms, the Ariane Sky Ranger shares the map-based control interface. The Sky Ranger is capable of longer duration flight, and can fly up to 50 minutes with a dual EO/IR payload. The Sky Ranger has a higher bitrate, IP-based network, and is capable of streaming HD video from over 5 km, with multicasting capabilities. The vehicle is all-weather capable, with an industrial temperature range and has a top speed of 65 km per hour. It is able to withstand wind gusts up to 90 km per hour. The Ariane Sky Ranger has a folding design that makes it quickly deployable. Aurora Flight Sciences Skate SUAS. The Skate SUAS is a man-portable unmanned system designed for the tactical user, military, police etc., but also useful for other applications where portability and operation from constrained environments are critical. It is a 2.2 pounds airframe coupled with a custom portable GCS. It has user-swappable payloads and can be equipped with a variety of EO, IR, and / or thermal imagers. Flight endurance is around 1 hr. The Skate SUAS was put into service with Army and Air Force units in Afghanistan in March 2013. China CATIC. CATIC of China is working on their own hand-launched man-portable UAV, the ASN-15, with an endurance of an hour and a payload of 6.5 kilograms, 14.3 pounds. EADS Tracker. European EADS organization is developing a small UAV named the Tracker, which features a wide-span wing, twin booms for payload and so on, and a central pod with tractor and puller propellers. It has a weight of 7.5 kilograms, 16.5 pounds, a span of 1.4 meters, 4 feet 7 inches, and an endurance of an hour. Elbit Skylark I and Seagull. In the spring of 2003, Elbit of Israel introduced 2 electrically powered man-portable UAVs, the Skylark and the Seagull. Both of these UAVs have a launch weight of about 5.5 kilograms, 12 pounds, a speed of from 35 to 70 km per hour, 20 to 40 knots, and can carry either a color daylight imager or an infrared imager. The Skylark I is of conventional configuration, resembling nothing so much as a large kid's rubber band airplane with a pod under the fuselage. It has an endurance of 1.5 hours. The Seagull is much less conventional, in the form of a boomerang-shaped flying wing with wingtip fins and a pusher propeller. Size, performance, and payload details of the Seagull are similar to those of the Skylark, but the endurance is stretched to 6 hours. EMT Aladdin. German manufacturer EMT has produced the Aladdin mini UAV for German forces. It has a range of more than 15 km and an endurance of 30-60 minutes. IAI Malat Bird IS and Mosquito. IAI Malat has also introduced their own small UAV line, designated Bird Eye, which includes the 5 kg, 11 pound, Bird Eye 500 and the 500 gram, 1.1 pound, Bird Eye 100. Sources also mention a Malat micro UAV, the Mosquito, though this may be the same as the Birdeye 100. Malat has been promoting the Birdeye 500 for both military and civilian uses, with civilian uses including urban security, crime fighting, and traffic observation. Layman Aviation Drones. Layman Aviation Ltd., the French manufacturer, has developed man-portable, 92 cm wingspan, lightweight, 1,25 kg, line of UAVs, LP960, 2007, LV580, 2009, LM450, 2010, with a common ground control system. All the UAVs are designed for civil applications, civil reconnaissance, civil security, mapping, survey and monitoring, digital elevation model, photography in general etc., and can make still aerial images and full HD or real-time videos. Layman aviation drones are launched by hand and land independently on the ground. The systems use electric engine and a pushing propeller on the back part of the aircraft. The wing is made of expanded polypropylene. The UAS have an advanced navigation system and an autopilot which enable the aircraft to fly with the range of 5 km and a flight endurance from 30 to 45 minutes. Layman aviation UAVs were designed to fly with up to 45 km per hour wind, 25 knots, in different climate conditions, humidity, dry air, with the temperature range from -25 degrees Celsius to +60 degrees C. Layman Aviation LP960 is a UAV for professional use launched in 2007. LP960 was designed for orthomosaics, digital elevation model, and HD vertical images for the needs of public and private sectors, mostly construction and geodesy companies as well as scientific organizations. Layman Aviation LV580 is UAV done for professional use. It was launched in 2009 for live day and night aerial survey. Layman Aviation LM450 is a UAV for professional use launched in 2010. It was designed to take oblique still images and HD videos. In 2012 Layman Aviation launched LA series of fully automatic micro civil UAVs, the LA100, LA200, and LA300. The work with Windows 8 touchscreen tablet which enables user to set up flight parameters and prepare the mission. All Layman Aviation drones are compatible with Layman Aviation Operation Center v2.00 working under Windows 8 operating system. Lockheed Martin Desert Hawk. U.S. forces are also using another mini UAV in Iraq, the Lockheed Martin Desert Hawk. It weighs 3.2 kilograms, 7 pounds, has a wingspan of 1.32 meters, 52 inches, and a length of 86.4 centimeters, 34 inches. It is made mostly of plastic foam, suggesting something like a Nerf toy, and uses an electric motor driving a pusher propeller as a power plant, making it very quiet. It is launched with a bungee cord, carries 3 small CCD cameras, has an endurance of about an hour. It flies mostly under autonomous control, with the pilot keeping track of what's going on with a laptop computer. The Desert Hawk was designed by Lockheed Martin Skunk Works for the Air Force FPAS, Force Protection Airborne Surveillance System, program on a quick reaction contract issued late in the winter of 2002, with the first system delivered in the early summer. It was designed quickly because it leveraged heavily off of technology and design studies developed for the MicroStar MAVs. However, in 2007, the U.S. Air Force FPAS office switched all of their UAV systems over to the RQ-11 Raven B. Desert Hawk did make the shortlist for the recent Netherlands Army Mini UAV program, but ultimately lost to the RQ-11B Raven B. The only military forces still using Desert Hawk are the UK Army. MA Vinci Sirius UAS. The Sirius UAS is a completely autonomous small airplane with a wingspan of 2 meters. The UAV combined with the image post-processing software enables one to simply obtain aerial images and calculate orthophotos and three-dimensional elevation models out of the image data. The flight planning is done automatically after selecting the aerial image area. The flight plan can be altered before.
Please subscribe and thanks for watching.